Right, we're off again on another epic adventure where we do some testing on this 3D printer, the BQ-Hurakan, Hurakan. I don't know how you're supposed to say it. But yes, we did some testing yesterday. We didn't quite finish everything. We ran out of time. We built it on Tuesday. We tested it on Wednesday, and we should do more testing today. So, welcome back, everyone. Hello, 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 and hello. The plan today is to show you the input shaper graphs. I made some graphs. I did have to redo the testing because it saves the CSVs in the temp folder, which apparently gets deleted when you turn it off, turn it back on again. So all of that data disappeared. Yay. So I just had to redo those, made the graphs, and now we can show you the graphs. They might be a little bit different from what we actually did yesterday, but they are taken from this machine, tested in exactly the same way. So we can take a look at those at some point. I also want to do a kind of speed acceleration limits graph, which is something we looked at a little bit when we did the Voron as well. Gives you an idea of what speeds you can achieve at different accelerations and vice versa. The other thing, what was it? There was another thing. I've forgotten the other thing. Oh, potentially changing between the kind of silent mode, stealth chop, and spread cycle. I'll do that maybe first, and we'll have a look at how that affects our maximum acceleration on the speed that we've already done. See if that improves it, and how it affects the noise levels as well. And probably anything else we can come up with. Oh, I also want to try and work out for a certain distance what the optimum is between speed and acceleration, and that gives us a choice. So if maybe for like, I don't know, the bed size or half the bed size, what's the minimum distance it takes to move across that? Is it with really high acceleration and low speed, or higher speed and lower acceleration? You know, where on our chart is going to give us the lowest possible time. I expect really high acceleration. No, because that will make the speed read. We'll find out, won't we? Probably somewhere in the middle. So yes, hello everyone and welcome back. What are we going to do first? I might leave the input shaper graphs till there's maybe a few more people here. So for now, I think I want to turn it on. I want to see what the noise level difference is and that acceleration difference between, good Lord, that thing's noisy. The difference between stealth chop and spread cycle. So stealth chop and spread cycle are basically two slightly different stepper driver control methods for moving the motor. One's optimized for noise. The other one is sort of better performance, kind of. I don't really know. Stealth chop is definitely designed to minimize noise. Spread cycle, I think, is designed to like lower overall torque or something. I don't know. Not lower torque, but shall we look it up? Let's see what they define it as. So there are different types of chopper mode. That's what they call them. Constant T off, spread cycle, and stealth chop. Spread cycle. By adding a hysteresis function, spread cycle overcomes the issues that a constant T off chopper introduces to your mechanical system. It automatically applies a fitting relation between slow decay and fast decay to create the optimal fast decay for that cycle. The function acts as a parachute that gently drops the current so it doesn't fall too quick, leading to an average current matching the target current. Besides resulting in a near-perfect current sine wave, the cycle-by-cycle chopper mode spread cycle also reduces current ripple and torque ripple. There you go. Stealth chop completely silences stepper motors by eliminating the noise caused by unsynchronized motor coil chopper operation. There you go. Bit of a wordy description maybe, but it's complicated stuff, eh? So got here. Where is everyone in the chat? Say hello if you're in the chat. Have you arrived? Are you here? Let me know you're all awake. I can see like 3 or 4. Oh, and don't forget to like the stream. Leave a like because reasons. Yay, hello, 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 hello. Maybe I should encourage people to say hello more often. So hopefully on our second screen we should have our Clipper interface coming up. Here we go. Let's start with homing. Eventually we'll get to doing a speed buggy, I guess would be the correct term. It's like a speed benchy, but it's a buggy. We've got the link in the description now as well as on the previous stream, so if you want to check out that E3D little buggy print, you can do that. So, how did we do this? So we're looking through this Andrew Ellis print tuning guide. It's a pretty sweet guide for tuning prints. This is going to drive a lot of what we're doing. This is pressure advance. What we're looking for is, here we go, determinant. We've not done this. Let's do the noise levels first. So home all, oh, we already did that. So it's pretty silent. We should do a noise test with like a few cycles at high acceleration. That's profile. Oops, here we go. So if we use this, we'll use this as a little test for noise levels. So we'll do it like accelerations 15,000, iterations 3. Good evening, Andrew. Hoo, 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 hoo. Okay, let the test begin. Why 64 microsteps rather than 16? What's particularly special about 64? So is this still pretty silent? So that's our cycles. Now we go and change. I think the TMC was on here. Yep. So we do, I mean, the run currents are all set, fixed as well. They could probably be higher maybe. So we set these to 0. X and Y, that'll do. What about torque? Less noise, but more torque? More torque, I think, is at smaller, fewer microsteps. Printer, no. Dashboard, I will. Ooh. Makes weird noises, that does. Hello, Ricky B. The x-axis is definitely making a very weird noise. It sounds like it's coming from the hot end though. Oop, wrong one. No, not up to max speed. I'm doing a... Ooh, it looks a bit framey. Why does it look weird and framey? So that was... these settings. Looks like microsteps is set on the axis configuration rather than the... So run currents, oh, Z is a bit lower, extruder is also lower. So max velocity is still 180. X microsteps. Does this, I can't remember on, I've never really adjusted microsteps in. Do I have to change the rotation distance down if I modify microsteps? I can't remember. You can just do microsteps, cool. That's the advantage, right, of not using steps per millimeter. Oh, was interpolation on? Where do we set interpolation? Is that on the TMC section? I think interpolate is true by default. So we've got interpolation on at the moment. That's a really odd noise. Yes, that. The y-axis is really quiet, but the x is super noisy. I wonder if it's the same motor or a different motor. Come on, let's go. Go brr, go brr, go brr, brr, brr. The bed is so quiet still. It's tempting to put the x-axis on stealth chop and the bed on spread cycle. Because it's very noisy like that. Wrong one again. Over here. What one was interpolation on? Is on the TMC. I am having lots of fun with this machine. I mean, Clipper's just quite fun to use. It's still noisy. That's such a weird buzzing noise. Can everyone else hear that? Or is it just me? That X just makes a weird buzzy sound. But it sounds like it's coming from here and not over here. Very peculiar. So this ribbon cable is starting to get pretty bent already. I feel like that might not be super durable. I saw actually today they mentioned this. They actually just offered to send me one as well because they don't know that I've got this one. But I don't know, because I did take the hot end assembly off and it doesn't look as easy as their render made it look. I might be wrong. If they can send me some like 3D printed file that allows easy adaptation, that would be cool. But it doesn't look that easy. So that didn't seem to change noise levels that much either. Obviously this is not very scientific testing because I'm not even measuring anything. What about that? Because in Clipper we set acceleration for both axes simultaneously, and the Y axis is much closer to its limit because it's much heavier, we can set this one to stealth chop, I think, and this one to spread cycle, because this is quieter than this. So we should be able to achieve similar noise levels, but with this one on spread cycle, which should maybe increase the performance very slightly. We might be able to get slightly higher acceleration. And we should be back to quiet now. Yeah, there we go. It definitely prefers stealth chop, that x-axis. That looks pretty good. Okay. I don't think I want to test much more there. Maybe we'll put these back to 16 microsteps. Maybe we'll keep Y on. No, actually, Y can be 16, X can be 64. That's probably my preferred. Come on, please. Oh dear. It somehow reset itself? Okay, there we go. I wonder what we can do about the clicky clacky pin. I don't know if there's anything I can do. Disassemble it, but I don't think I'll be able to trigger it while it's disassembled to see where the noise is coming from. Let's have a close look and inspection and see if that'll help diagnose the source of the noise. That's gone really... Yeah, it is on the retraction of the probe. I've changed my mind as well. This is going back to what it was. Do-ba-do-do. Do-do. Or was it 32 initially? Let's try 32. It's purely the probe. There's no ZN stop around at all that I can see. Yeah, X and Y have physical end stops. I'm not sure why they didn't just do sensorless. Good evening, worst. X is nice and quiet. There's no screeching from Y, it is just a little bit louder. That should be fine though. So let's try that 20. It's 30k yesterday that we failed at. Let's see if we've got any better. Yeah, I know my pronunciation of things is not good. On the upside, at least you know when it's working. Because you can hear it from a mile away. I guess the reason they didn't put silicone in it is it gives it a bounce or something and it ends up just shooting back down. I don't know why you keep getting notifications about it. I can't answer that. But maybe you'd like to watch. Presumably you're into 3D printing. Question is, did we survive that test? So we should see these different by no more than the micro steps. Yeah, that looks good. So we might be able to go more. So I also want to try and populate this little table. Oh, you can't see. This table. So we have like speeds of, say, something like this. And we find out the max acceleration for each one, and then we plot a graph. Okay, at least you're into 3D printing. It's not just sending out suggestions to random people. That would be quite funny though. People that just have no interest in printing. Yeah, you might like this. There's some keyword or something I've used that's mixed into some other community thing as well. Funny for me, probably not so funny for the people getting the notifications. 437, 441, 918, 918. We're all good. We're just cranking it today. We've just been through that, Carlos. You're a little bit late. Soz. I don't know why I said that. So I did a little bit of a test on X and Y with Stealth Chop. It makes the X really loud. Putting spread cycle, it makes it really loud. There's some weird noise. Tried a bunch of different configurations to see if it would change, but largely it didn't. But it did change. I've changed it for the Y-axis, and that is now on spread cycle. So hopefully a bit more torque available there, and it stayed reasonably quiet. So now we're just going. That most famous people are duking in the work. Maybe. I think you could be right there. It could be that. $37,437, $438, $13,9. Oh my goodness, this is craziness. Let's just go hopefully way past. I remember doing this on my bloody Vora. It took ages to find the limit. I kept like just upping it by a really small amount each time, expecting to find the limit and not wanting to break anything. We ended up going on for like half an hour increases. It took forever. You're probably right there. I think this needs a better thing. I don't like this. I don't like this really. It's not great. This down here, this joint is just gonna fail so quickly. $434, $440. This is insane. We've made it to 45k. 55k. Don't forget to hit the like button, by the way. We've got like 45 people and only 16 likes. Disgraceful behaviour. Come on, little printer, you can do 55k. Motor is pretty warm, but not like hot. Hot. Shall I have my face on here too, so you can still see I'm here? I do exist. Look, I'm on camera. Oh, this is probably a bit smaller, isn't it? So basically what I'm doing each time, for people that don't know, basically after the test we're looking for skipped steps. So this is the micro step home position of X before and after, and of Y before and after. So because of some slight differences, we're likely to get some change, but we want the change in this number between here and here to be less than the number of micro steps, so less than one full step. If it's less than one full step, which for X I think, what do we have, 64, and for Y 32, then it means no skipping and we can go faster. And it's just successfully done 55k at 100 millimeters, 180 millimeters a second. So 180 is pretty slow. So it's not really slow. With a Voron we were doing this at 300, so we're going to need to up it as well to see where we get to. But for a printer that's £320 or something, link in the description, affiliate link if you want to get one. It's pretty decent looking performance. I was not expecting this to go. I was sort of thinking we might end up in the mid-30s, but now we're at what, 65k, and all we did was change a couple of small settings. How is this still working? There's something... This should have skipped steps by now, surely. That's 65,000 millimeters per second squared. 37435, 440, 13918. Acceleration of 65,000. Well, I just need to find a limit, 85,000. Is that a proprietary bed? It's a spring steel, but it's very similar to other beds in its general design. There is a slight difference in the heating capability. So you can probably see the inner zone here, and then the larger outer zone. So the in one is like a 100-watt heater. If you're just printing small things, it uses a bit less energy. Or you can use full zone heating if you're doing something larger. It's better than the one from the B1, I think. I did have a B1. It was a little pink thing with weird brackets. The sheet on that was not PEI, it was just powder coated paint, and it was like super duper flimsy. This is probably not quite as thick as I'd like it, but it's definitely an improvement. Yeah, the one on the B1 just felt a bit like tin foil. Like it was so thin. I don't think I have it anymore. I might actually, you know. Yeah, this one's... It's definitely thinner. This is an OSAC one. It's definitely thinner than that by quite a bit. But it's not... It's doable, and it is spring steel, I'm pretty sure, because I can bend it like this and it's still flat. So I'd say it's a pretty good bed. It might not be perfect durability or what, I don't know, but it looks like it's promising what it is. How is this still succeeding? What was that? 85,000? I'm starting to think I must be doing something wrong. There's no way this printer should be doing 105k acceleration. We stop when, at the end of the test, this number and this number are more than our micro steps different. In other words, I think it might have done there, it skips some steps during its test, but it doesn't seem to be skipping, which means the motors are delivering the torque that they should be. Well, no, sorry, that's incorrect. The motors are delivering the position of axis that it should be. 441, 435, 917, 919. I might try this at just a few more iterations, because I think it might have been getting a bit close. It sounded like it could have been. You can see we've definitely had a greater microstep deviation than we have up till now. It's not a lot, but it's a little bit. So what we'll probably find, if this is going to do like 110,000, 100 will probably do something ridiculous like 200k. Or maybe we'll do it in thousands, it's easier. And then maybe 200 will do 50, and 250 will do 30, and 300 will do 20 or something. And then we take this and we make a graph chart. And it'll be a graph that looks a bit like that, which you can't see. And then you have speed on one side, acceleration on the other, and then you can pick what's good. Yeah, I'm going to be increasing the speed because we really need to. it won't move any faster. The speed is the same. It's just getting to that speed quicker. Because it's acceleration that we're adjusting and not the maximum speed. Give me numbers. That was absolutely fine. Okay. So we've tested, what did we test? 105k. Limit not reached. Because it's going to go stonkingly high. When you have low speed, the acceleration can go crazy. I think it's going to be better, as Alan suggested, if we now go high and bring the acceleration down. So if we put speed equals 300, and we'll put acceleration down to maybe 15k. So this you will see go significantly faster, but the acceleration will be lower. But it will still be almost instant. 15k acceleration is still pretty high. Well, relatively speaking. Visually to the eye, you probably won't notice much difference between like 15k and 80k. I'm pretty sure it does, Alan. We shall see. Yep. That's faster, all right. Oh yeah, it does. Yeah, that works. So hopefully we should find the limit a lot quicker now. Well, this limit. Each speed will have its own different limit. That's why I want to plot this, plot that graph that I showed. So hopefully we'll find it pretty fast and we can refine it. 300 millimeters a second speed is pretty crazy for a small machine like this. I wonder if they have put a decent amount of work into the stepper motor design and stuff. I think a lot of these printers just tend to buy whatever stepper motors are cheap and available. Are we going to do 20k at 300? The wheels are making some weird noise. I don't think the wheels like going this fast. I think it's just success after success after success today, isn't it? This is crazy. $36 to 41, 17 to 16, didn't fail. I really need to find a failure. 30k, there's no way it's going to do 30k. I think. It only just managed 30k yesterday on 180 millimeters a second. The small changes I've made today shouldn't be that big a difference. We're 45 minutes in. How has it taken 45 minutes? We've not done much. It's these little moves that's probably going to... Yeah, I did it! This is crazy. Did it succeed though? Did it make it? Did it make it? Did it make it? It did! This is ridiculous. Hello, Sam. 30k? What the hell? This should not be possible. How is this working? Some witchcraft they got going on here. Is it going to succeed? 40k acceleration. It makes some weird noises. No way. 40k. It did it! What the hell? This is impossible. Shall we try some higher iterations? How about that? We'll do 40k 6 iterations. It's not a lot still, but we'll see what we get to. I'm trying to find some limits for you people. I just can't find them. This is bonkers. Apart from the weird noises from the V-slot wheels. I'm pretty sure it's from the wheels. Has it done that? Is it just constantly smashing it? What's the result? What's the result? Oh, have we found the limit? 35 is 511. No, not quite. We've got to go higher. 50k. Right, shall I just do something silly just to prove it's going to work? 80k. Have you done any work on slot wheels versus linear rails with regards to speed? No, only really like durability. V-slot wheels end up wearing out pretty fast. I've not like actually done testing, but one of the printers I had, if you got like big things with printers with V-slot wheels, they wear out pretty fast. And then if you try and add more, then they don't align properly, and then one wears out really fast and all this kind of stuff. It's like a, what was it, the Top Gear thing? What's the fastest car in the world? It's a rental. Whatever. Is this actually doing 80k? You're supposed to fail! This is absolutely nuts. Well, at least if this succeeded, we saved ourselves some time going up slowly. No, printers don't get worn out. It's actually just done 80k at 300. I'm so convinced I'm doing something wrong. Sub 2 minutes on a bed flank. This is just mental. It is going to need a higher flow hot end because we're limited to 185 millimeters a second. I mean, I'm not sure I'd print continuously like this. The V-slot wheels are kind of screaming at me to stop. But the stepper motors are just like, more, more, more. More power. The y-axis is fine. It's the X that's going weird. I suspect it's some misalignment. If the V-slot wheel is like slightly tilted relative to the rail, it'll probably be rubbing a little bit instead of rolling perfectly smooth. Did it just do 100k? Oh, there we go. That's, so now you know that's steps. I told you it works. I knew it works. I didn't doubt it, not for a second. So here, the difference between this and this is significantly more than our micro steps. So we can be sure. that we cannot do 100k at 300 millimeters per second. But we could do 80k. So let's try 90k. They're just BQ branded stepper motors. I mean, they've got, it says a 42 SHDC 406, no, 96Z. It's difficult to read numbers upside down. Okay, so we know at 300, it's going to be less than 100k. It's absolutely screeching. How is it going this fast? Woo! The motors are not that hot. I could probably keep my hand on them a little while. So they're not anything like 100 or anything like that. Probably, if I had to guess, maybe 60s. Maybe not even that warm. I don't know the why. It's in the enclosure. I can't see it. I can try a thermal probe, but I don't know. A laser temperature doodah, but I don't know how accurate it'll be. Oh, it's not even 6, it's like 45. It's barely even warm. It's easy peasy mode. I expect maybe the Y is hotter, but I think the temperature is just really based on current. Did we succeed? No, Y skipped that time. 13,000 compared to 12,000. So maybe try 85k. Let's take this down a bit. At least it should be a bit quicker to find the lower speed ones after we've done this one. That's the only consolation. Because we've got a fixed range in which they can appear. Go! 85k. Come on, printer, you can do it. Zip, zip. Think it skipped on that little bit. I think I can see this wheel being not quite aligned. Did we succeed? Did we succeed? Did we succeed? Come on, tell me. Tell me the truth. No! Okay, we'll call it 80k because 80k succeeded. We could hunt down the tiniest difference in there. So now we'll drop it to 200. We'll skip this one. Actually, we won't, because this might be a valuable region. So speed 250. And no, it should go up. Huh? No, what? Yeah. I'm being a dum-dum. Yeah, the max acceleration is just going to be higher than that. Okay, so I guess this would be useful, but it's so high out of the range that maybe it doesn't really matter. Considering the limit for, so the input shaper was 3100, wasn't it? Will it hit 80k again? Sure. Do you want to do 80k again? While I work on... It should just do it continually now. That's the thing about when testing robots and not humans. Robots are the same every single time. Until they break. So watch me hit the 60k. This feels silly. This maybe we'll do at 60k. This will keep it a lot lower. So parameters. So maximum volumetric speed we worked out to 13.2, so we'll put a little bit below that. Maximum sprint speed 300, default acceleration, perimeter acceleration, this is the one we want at 3000. The default acceleration can go really high, 15k, 30k, 40k. We'll try it as a speed bench and see where we go to. Travel acceleration, first layer acceleration, we'll do this for first layer. Infill speed, we can go for perimeter speed, maybe we'll do 150. Infill speed, we can probably push 200. Gap fill, maybe 150. Perimeter external, we'll do 100. This is maybe a bit too generous, I'm not sure. I mean, this is going to limit it anyway, I think. don't know why when you search bench sheet it doesn't find 3D benchy.stl. What were the results? Let's have a look. 519 to 526, 12377 to 12377. There you go. 80k, 10 iterations, no worries. So it's probably going to be cooling down. That's going to be our first problem, I think. An hour. Do we have a... I'll just do a speed PLA, it sounds daft. Layer time goal. Second. Zero reduction. Oh, my nose is going. Oh, excuse me. That's 38 minutes. Oh, look how much those layers are changing. Still slowing down a lot up here. Oh no, this is layer time. Volumetric flow. Oh, how many blooming perimeters have we got here? Blooming hell, like 4? 5? Infill 10% cubic. That's now 28 minutes. Is 28 minutes quick enough? We can probably up that acceleration, can't we? Let's go more. We'll go for the maximum 180 on the internal and external perimeters. Infill speed. It's going to be kind of garbage because I know the hot end won't keep up. This is the problem. We can just basically do everything at maximum speed. "27 minutes. Layer time goal is at 1 second. .1 seconds. 27 minutes. Travel speed 300. Maximum printing speed. This is what we need to have at 180, I think. Let's try 190. It's pushing the limit. Perimeter acceleration. Let's go send it on this. External. This is the one that's going to be 300, say 100. So I wouldn't say this is a speed benchy. It should come out, I think, looking reasonable-ish. The cooling will probably not keep up. That's going to be our problem, I think. We should have this. Oh, it's supposed to be the buggy, wasn't it? We're buggying. Oh, rats. Where's the buggy gone? Okay, maybe we'll just have to do benchy. We're about to find out. I think the first layer was okay when I did the first print. No, it was not great, was it? We should do a first layer test if we can. Let's send it. What's the worst that could happen? Many things. I'll just hit the layer down button, this one over here, when it gets going. Oh, it's exciting. Let's go partial bed, full bed, partial bed. Oh, we don't need the ADXL connected, but there you go. Yeah, it was quite a lot high. We'll see how that pans out. There's me setting up cameras halfway through the stream. So professional. Yeah, so you can set it to full bed if you turn it to the on position, or center bed for the other position. Come on. It does have two cooling fans, so there is definitely more cooling potential than your standard bed slinger. But is it going to be enough? No, probably not. But then I am pushing it pretty hard. Probably, maybe. I'm not sure exactly how it'll come out. Fans are starting to go on. PWM's starting to go down, so the bed's close to temperature. Let's go. Let's go. Come on, little printer. What are we waiting for? What are we waiting for? Oh, nothing, as it turns out. There's a bit of smudging on the nozzle, so we'll just... Do we want to see this screen, or do we want to see the close-up? It's going to be such a train wreck, isn't it? I probably could improve. I mean, this process could be faster, couldn't it? Given what we've just come from, this now looks extremely pedestrian. The train wreck or the glorious success. It's probably going to be one of those two. Was that a 12 minutes on an unmodified straight out of the box Ender 3? And did it actually look half good? I'm not trying to go to just make something that looks kind of like a Benchy. I want something that actually looks like a print, like it was deliberate, like it's usable. Not that Benchy's particularly usable for much, but you know what I mean. Ooh. I think the tool head looks cool, but the actual hot end is not quite. Right, here we go. Is there any filament properly installed? No, but hopefully there is now. This first layer is not great. Baby step, baby step, baby step, baby step, baby step. Oh, look at it go! That's some serious acceleration. I've never seen a bed slinger move quite like that. Oh, by the way, there's a link below if you want to buy one. What timing? Seriously though, there is. It's an affiliate link, which helps me and doesn't cost you anything. The front of the boat is going basically vertical. Yeah, the cooling is just not enough. ABS, it might be okay, but you need some serious cooling to be able to print this fast. Go get the desk fan. I think pressure advance might be making a mess as well. Yeah, the cooling fans are really underpowered. The top of this boat is going to look a mess. I think I might have to go get the fan. Oh, sorry, that's in the way. You want cooling? Here's your gosh darn cooling. Yeah, Noctuas are great for silence, they're not great for airflow. You need, I mean, some big like 120mm fans or something. They do have some performance options, but not in the small sizes really. I'm not sure how much. Oh, it's come off the bed. It's cooled too much. Right, pause this. Stop that, stop that, stop that. Right. Let's get that out from under there. Right, let's save the offsets. And I'm just going to print again. Turn this off. Trouble is we start to hit like bed cooling issues and stuff with the fan on. I think it's going to end up cooling the bed down. The only reason it came off is because the first layer was not really adjusted. I'm going to get better first layer. Better first layer. Lots of extra cooling. Kind of want pressure advance off as well, to be honest. Or maybe it is. We'll see. Hello there, Sanity. We'll try again after this. If this one doesn't work, we'll... I mean, we're definitely hitting flow rate. I can try and show you this one while it's doing the proby things. So you can see that as it started to do the bridging, that's at like maximum 300mm a second. There's nowhere near enough filament. Got hit by the bed. Oh, come on, focus here. So on the sides here, it's actually looking pretty good. In terms of extrusion rate, I think we're fine. But the bow just was a mess. I think the gaps might be pressure advance, potentially, or just collection on the front of the bow where it's all just collected up. The power supply is a 300 watt. It says it's an LRS 35024, which is a Meanwell part number, but it doesn't say Meanwell on it. So it's a 350 watt fan assisted 24 volt power supply. Do you like the title change as well? Is that good? Is that more clickbaity than the last title? Don't forget to leave a like if you're watching, because that's a good thing to do. That's bad. There's the whole party in the back watching this. Oh, the party of printers behind me. They're all feeling threatened by the new cheap printer. Right, leave it off for most of the first layer. It looks like there's actually quite a bit of plastic collecting on the nozzle, unfortunately. I think our bed might be a bit too close now, but that's for speed is going to be better than too far. Let's do a couple of layers as normal. It's not clickbait because it's true. It did do 80k. That's legitimately what it did. What are you talking about? This is the fan. We've got a new 400mm fan. How big is this fan? It's approximately a 320mm fan. The trouble is getting the air under there. I don't know how much it's going to be getting in the right place. We might still end up with a bit of a saggy boat. We can up the fan to maximum, well, it's only 2, but it's more. I will watch the temperatures because we don't want to be going, we're hitting thermal runaway if we're not careful. $320 to 15mm adapter. It's just like this enormous funnel off the front of the printer. So I think although we're not going to, I don't think we're going to end up with a beautiful benchy purely because of cooling, but I think it does show that the printer's actually got quite a bit of potential. The fact that it's moving this carriage and bed around this quick, it's pretty primo stuff. The reason why it's that fast is because of input shaping. Yeah, basically. Well, it's not the reason it's that fast. It's one of the things that helps it be that fast. There might be. I'm not sure the cooling built into the printer is doing much relative to this 320mm fan on the desk. Ooh, that made a weird noise. Oh, maybe it was this. Needs more cooling. Maximum cooling. I think it was 28 minutes, but we don't really know. Second screen, this is the estimates on here. So it's done 8.5, and it says it's going to be another, oh, more? Less. 10, 17 minutes. So it should be maybe 25. Sam, I'm guessing they sent you the same message they sent to me earlier. Was it today or yesterday? That sounded like the print releasing. Revo H2 upgrade. It's weird, you know, it's good for that nozzle change. And if you want to do flexibles, obviously. But despite this hot end not being amazing, it's more of a quality thing than a flow rate thing. I don't think Revo, without any high flow capabilities, is going to be faster than this one, and the added weight is obviously a negative. Yeah, I don't know. Everyone's waiting for high flow Revo. You should be able to achieve slightly higher flow rates with PLA than ABS. Not by much, but a little bit. But obviously, you've got to cool it. The only limit on this machine at the moment, well, the only limit. I think you could be very happy with every part on this printer printing at nearly this speed, with the exception of the cooling fans. Unless, I mean, I guess if you're printing something much bigger, then this speed would be quite doable. Yeah, the H2 Lite, it's like a... Yeah, it's like they've modified the body, but it's not Revo, that one. So yeah, I mean, having the H2 would probably give you a bit of a flow rate bump from about 13 to, what was it, about 18, somebody said. I can't remember what I tested with Revo. Didn't I flow rate test Revo? I can't remember what I said for that. No, PLA should get higher flow rates than ABS. But it's no good for printing fast things tiny, because you have to cool it. The extrusion force that I tested suggested that for equivalent flow rates, PLA requires less force. Flow faster is a pretty general term. I mean, I've tested it quite extensively at this point. My testing is based on force. You can achieve a higher maximum flow rate with the same hot end with PLA than you can with ABS, because it requires less force to extrude than it does ABS at a reasonably high temperature for both. I'm not sure quite how it's dealing with this 7mm of retraction. I just noticed your revolt joke. Well, it's a Bowden. You need boatloads of retraction, don't you? I tried 3 before and it was super stringy. I've not done a retraction test. I'm literally just guessing. The B1 profile, which is what this is supposedly based off, suggested, I think, 7mm on the Cura profile. I think that's what we discovered in the last stream. That's one way you could speed up the print. Just impaled this bench sheet on the trees, isn't it? Amazing, eh? Good. But it's not really anything to do with density. Think about aluminium, metal, steel, brass. They're all more conductive than the plastics, and they're more dense. If anything, the density, higher density would help them more conductivity. But it's not really the property that determines flow. Ooh, I think we skipped a step on Y. So might have to take it down a bit. Sanity, how many band hammers do you own? Is it too many? So far. Oh yeah, we skipped. Sad times indeed. Paul, did you change anything? Did you add a display by any chance? Or a camera? Oh. I've had problems with using displays and cameras. They end up drawing either weird current or just interrupt stuff's ability to use Wi-Fi for some weird reason. Probably software related, but thought I'd share. That's a problem I had. It's probably not a Pi problem if it's a problem that other people are having, right? It's probably software something. I don't know why I left it on this screen, sorry. Heard yesterday that input shaping should ship as experimental in Marlin. As interesting as that is, and that's also great, I'm not a fan of using experimental features. If I'm asked to do testing, fine, but I'm not going to go and install it on printers that I want to be using. So what does determine flow rate? I was under the impression that flow rates were determined by how fast the materials melt. Well, yeah, but that's not anything to do with density. Bye, John. Enjoy your work. Ta-da! Thermal conductivity is one of the primary properties. Flow rates, hot ends, nozzles and melting is all extremely complicated. I've had discussions with I think they do process engineering. I think this person I talked to. So they do lots of thermal flow and chemical calculations to do with heat transfer and all this kind of stuff. And the spreadsheet we were looking at and discussing, my goodness, it's insane. There's so many different variables and parameters and material properties and lookups and this changes and that changes and who gee what's this, and it's just like a really simplified version of an actual hot end. It is absolutely crazy. There's not just one thing. Paul, what might be worth trying, I mean it's probably a pain in the ass, is to take it out of the printer entirely, use a different SD card and do just like boot it up into something else different, a really simple system, because that way you'll see if it works, if like the hardware is working or if it's software related. Because all the time it's in the printer and connected to other stuff, you've got so much stuff that could be causing problems. And also, don't use Wi-Fi. So we've got quite a lot of skipping. The retraction is still not great. which is going to be down to the hot end. It's a very artistic looking benchy though, I must say. You probably want to try every single step before you do something else, because pies are so valuable now. You don't want to be binning them. I've got two that I'm convinced are broken, but I'm going to keep them just in case they're not. This benchy does indeed look pretty terrible. Sorry about that. I did say I was pushing it quite extreme. It's more of a shipwreck. Captain Birdseye would be proud of that. Yeah, probably. I don't like speed with Bowden. It's not a good combination. We're currently at 23 minutes 50, so I think for a bed slinger, it's still looking pretty good. We wouldn't have to change too much to get this to still be under 30 minutes. Speaking of lights, da 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 da, pluggy pluggy plug, pluggy pluggy plug. Lights. These are RGB lights. Very yummy. Available now on the website vector3d.co.uk. There's VLMPs as well. Oh, it's not down here, it's over there. Grab a linear motion press. It's a fine line with choosing what settings I was going to do for this benchy. Part of me was going to be like, well, let's just do one that looks really good. And part of me is like, well, let's do it so it's printing absolutely crazy. But which really demonstrates the printer well? I don't know. People want to print quality, but they also want to print fast. Now, obviously there's like an optimal place in the middle where you get a perfect benchy that's also pretty quick. But it takes a lot of time to find that. On a stick. It is. We've got, my version is Daybreak on the stick. So obviously they're based on the Voron ones. I have basically changed the entire design. Well, all the electrical design, there's obviously some similar things. But my RGB ones actually came, I finished my RGB ones before Blam actually did theirs, so my short ones are a slightly different length. And I have a bunch of those on the website. Is this running Klipper? Yes. That's why we have this really funky main cell interface. Boom. Look at all that. All you could possibly want. Height maps, console, G-code files, G-code viewer, which takes a little extra time to load, especially I guess in the middle of a print. Oh, it actually moves the nozzle. Yep. Got all these things, machine settings, modify your firmware just by editing a text file. So good. Love using Klipper. Now we need someone to do light stick with 144 density. If you want a 144 density, I'll make you a goddamn 144 density. But they're going to be more expensive. Well, it is a bench sheet. I mean, if you look at it from this angle, there you go, it looks like a perfectly good bench sheet. Just a little bit of stringing. Apart from, if you turn it to this way. See, it's a very artistic bench sheet. It's very expressive. From this direction, it's fine. You look at it from this angle. Amazing fast bench sheet. It's amazing just how fast that illusion falls apart when you turn it. Oh, maybe the STL just looked like this. But like flow rate wise, we've kept up reasonably well, I'd say. It's definitely on the edge because you can see it's matte textured, which is generally what happens if your hot end is slightly under temperature, which could be even more the case with this one. I'm not sure how good the temperature probe position is compared to the nozzle. We can see exactly how long. 23 minutes and 56 seconds. Yes, it has auto bed leveling. So you can see here. You'll see when it comes back to the middle, this probe in the center of the... Here. There you go. So it uses that to probe the bed. So for example, if you want to do a height map, or a bed mesh as people say. Oh, don't want that. Now, I've not set this very quick. You could definitely do this faster. Yeah, the limit was 30k yesterday, but we hit 80k today at 300 millimeters a second. Absolutely bananas. Oops, it is. I can't put that anywhere where it's going to stay on the camera. I changed a couple of settings. I changed the bed to spread cycle instead of stealth chop. I can increase the Y motor current. I mean, it's Y, as always, it was always going to be Y that's hitting that limit because it's much heavier. X doesn't look like it skipped a stool, which is why it looks really good from this perspective. I mean, it's really good as an exaggeration, okay? I understand. But why there's no skipped steps in this direction. Y skipped, X did not. Y skipped, X did not. It's around £350, I think, is the price at the moment. For anyone that fancies getting one, there's an affiliate link, so it doesn't cost you anything extra. It gives me an extra kickback. So, great way to support the channel. If you fancy getting one, don't have to get it now, but go for it. We actually had so for difference on chopper modes, So this is trinamic. The coil of the electric motor, like a stepper motor, has a certain inductance, meaning it can save energy for a limited time. It also means a certain current can be held in the motor coil without feeding new current to it. This characteristic means you can save energy when driving a stepper motor by using a chopper classic chopper mode. I think that just means classic chopper mode, like constant T off, or an advanced chopper mode like Trinamic's spread cycle or stealth chop. So spread cycle adds a hysteresis function and overcomes the issue that constant T off chopper introduces to your mechanical system. Automatically applies a fitting relation between slow decay and fast decay to create the optimal fast decay for that cycle. At high RPM, where classic T-off chopper modes show excessive deformations caused by back EMF, spread cycle remains highly effective. So basically, spread cycle is good at high speeds, but it is a little bit louder at low speeds, whereas stealth chop is basically optimized for low noise. So if you want your printer to be like maybe printing in the night in the next room, and you don't want to hear it, that's a good option, but it will be a little bit slower. So if you want to check out more about Trinamic stepper modes, you can read that there. I do want to have another go at this 80K because people might have arrived now going, oh, that's bullshit. Here we go, test 300, acceleration 80K. Yeah, just to make proof, just so my title isn't bullshit. It did it earlier, hopefully it does it again now. It's been busy printing now, so maybe it won't. We'll find out. I don't know what the Y stepper motor is. I can have a look in a second after we do this test. The V-slot wheels make a weird noise, but it does do 80K. I forgot about the weird noise. I'm pretty sure it's just that this wheel on this side is slightly lopsided, I think. Maybe a tiny bit. It does make a weird noise. I did 10 iterations, didn't I? I didn't mean to do quite so many iterations. I'm really not sure exactly what the sound... I'm pretty sure it's misalignment of the wheel, so instead of just rolling perfectly, it has to slip as it moves. So the faster you push it... Could be that the belt tension's a bit low. That could be... I never really adjusted that. So that could be a factor. I might just try that again. With fewer iterations. See if that... You could put a linear rail, but I don't think it's really... I mean, this is a great test as a demo of maximum performance, but it's not necessarily something you're going to be printing at all the time. This bench sheet, I didn't actually print with 80K acceleration. I did go pretty high, but not 80K. But in the middle of a print, you don't want any risk of something like that happening. So you print a lot slower than this. There's not much speed advantage, I don't think, realistically, between like 15, 20k and 80, because you're getting to your maximum speed so quickly that the time you save is minimal. I think it might have been belt tension. The belt tension was too low. The linear rail would, yeah, you're absolutely right. If you were going to go more speed, then maybe a linear rail would be a nice option. But I don't think we've done too bad. If I was going to do upgrades, cooling would be the first one. Because I think, seeing as you can't really print ABS outside of an enclosure anyway, so it's not really an ABS printer, you're going to be probably printing a lot of PLA, maybe PETG, but you're going to want more cooling if you want to try and push this printer fast. Oh yes, I was going to check the motor, wasn't I? Can I do this without breaking stuff? This is a good question. Probably not. I might turn it off just to be safe. And because this printer has klipper, so it's running a Raspberry Pi type device, which is running off an SD card, it's a good idea to always shut down the printer. So you use this command up here, from here, shut down. Before you turn it off, you want to let this computery part properly shut down before you just pull the power, because it can cause corruption in the SD card if you don't. At least that's true with Pi. I don't think it's going to be any different with the CB1. Hopefully I left it long enough, especially after lecturing you about it. Whoop, there goes the bench sheet. Who's writing this down? Somebody's got to write this down. I'm going to read the stepper motor number. It's 42SHD C1060Z-16D. There you go. That's the motor. Now you know. If you want to see it closer up, you'll be able to see it in the first video. I had it upside down before the assembly. Oh, you wrote it in the chat. Great idea. Two of you. Okay, Googling it doesn't come up with anything. I didn't necessarily announce the dashes in the right place. I know, I did. There was only one. But 42, I guess, is probably the length, so it's probably a 42mm stepper motor. I think that's going to be the same as this one on the side. 42 SHDC 1060. Oh no, this is a 4069Z-18D. So that even the X and Y motors are different. Okie dokie everyone, I think we're going to call that a day. There is still probably more I'd quite like to do with this printer, but I've run out of time for today. So maybe we'll just do some more another time. It's fun just torturing a printer, isn't it? I want to try and improve quality of benchy. Now we've got benchy, we've got wibbly wobbly, slopped over, y-axis problems benchy. It'd be good to try and refine it. I mean, we're going to have cooling. I don't really want to do much in the way of like designing massive upgrades and stuff. Maybe we'll get into that, but think this is just quite... It's needing something that actually is a benchy. I think that would be a good place to get to. Anyway, hopefully you all enjoyed that. I certainly did. Of course, BQ provided me this printer for doing said review, but they didn't pay me anything. You can get one via the affiliate link in the video description. I can't remember if they're orderable now or on the pre-order. But anyway, there's a link in the description if you do want one. And that is an affiliate link which gives me a bit of kickback to help support the channel, but does not cost you anything extra. So thank you very much. Also, don't forget to check out VLMP, the vertical linear motion press, the heat set insert press for threaded inserts, or heat set inserts, whatever you want to call them, and Daybreak LEDs, and divider PCB, and all sorts of other stuff at vector3d.co.uk. Wicked shop, wicked stuff, wicked products, more coming soon as well. So there's a newsletter. I made a newslettery thing. You can sign up there as well. So when the new things come, you will know. I think that's all the end of stream ramble. I will see you next time. Good evening and goodbye.